In this video, I'm going to go through numbers 11 through 13 on the review. All of these essentially have the same direction. We're going to find the second derivative on all three of these equations. The first two, we are then going to evaluate at a number. And then the last one, we're just going to find the second derivative. So on number 11, we're finding f double prime of 2. So I need to first find what f double prime is, and then I want to plug in 2. So the first derivative of f would be, I again want to think of that as 4t plus 1 to the 1/2 power. So that's going to be 1/2 times 4t plus 1 to the negative 1/2 power. And then we're going to chain on the derivative of the inside. So we're going to chain on the 4. And I'm going to actually simplify this a little bit to make it easier to do my second derivative. So that's going to be that f prime is going to be, I'm going to multiply the 1/2 and the 4. So I'm going to call that 2 times 4t plus 1 to the negative 1/2 power. Now I'm going to find the second derivative, f double prime of t. And to do that, again, I'm just going to use the power rule. Now, when we have that 2 out front, I just need to now multiply the negative 1/2 down by that 2. So that's going to give me negative 1, 4t plus 1 to the negative, I need to subtract 1 from negative 1/2, so that's going to be negative 3/2, and then chain on again the derivative of the inside, which would be another 4. So again, I'm going to multiply the 4 and the negative 1 together to put that as a single constant out front, but I'm also going to go ahead and evaluate. So I'm going to do f prime of 2. Again, that's going to be a negative 4 on the outside, and then we're going to do 4 times 2 plus 1, and then to the negative 3/2 power. And then we're going to evaluate this. So we've got negative 4 times, on the inside we would have 9 to the negative 3/2 power. So evaluating a negative rational exponent here, the way I would do it is, remember this is power over root, and then the negative is going to mean reciprocal. So I'm going to do the root first. So the square root of 9 is 3. 3 to the 3rd power is going to be 27. And then negative would mean 1 over 27. So what I'm going to end up with is negative 4 times 1 over 27, which is going to give me negative 4/27. Number 12, essentially the same direction here. We're going to find the second derivative, and then we're going to plug in pi over 6. So the first derivative, g prime of theta. Now I actually have a product here. I have theta times sine theta. So I'm going to use the product rule. So we're going to do the first times the derivative of the second, which would be cosine theta, plus the second, sine theta, times the derivative of the first. Well, the derivative of the first, since my independent variable is theta, the derivative of theta is 1. Like, think about that as like being an x, right? So the derivative of that would be 1. So I could put times 1 here. I'm not going to do that. I'm just going to leave it as theta times cosine theta plus sine theta. Now, if I could simplify this, I would, to make it easier to do my second derivative. Unfortunately, there's not much that I can do, so I am going to go ahead and do the second derivative. I'm going to need to do the product rule again for this first part, but for the second part, I'm just going to be able to take the derivative of sine theta. So we'll go ahead and find the second derivative. Again, product rule on the first part, so the first times the derivative of the second, which would be negative sine theta, plus the second cosine theta times the derivative of the first, and the derivative of theta is just 1. And then I can do plus the derivative of sine theta, which would be cosine theta. Now I'm going to make this look a little bit better before I plug in pi over 6. So g double prime of theta is going to be, I'm going to make this negative theta sine theta plus 2 cosine theta. Now I can evaluate at pi over 6. So g double prime of pi over 6 is going to be negative pi over 6 times the sine of pi over 6 plus 2 times the cosine of pi over 6. So get out those unit circles. We're going to end up with negative pi over 6 times the sine of pi over 6 is 1/2 plus 2 times the cosine of pi over 6, and the cosine of pi over 6 is the square root of 3 over 2. So we're going to end up with this product would be negative pi over 12. And then root 3 over 2 times 2, my 2's are going to cancel out. I'm just going to get plus root 3. And there's not really much I can do at that point to simplify that any further. So negative pi over 12 plus the square root of 3 would be my answer there. Number 13, it says to find the second derivative, and we have x to the 6th plus y to the 6th equals 1. So what you could do here is you could rewrite this solving for y, and then we could find the second derivative. That way we could use implicit differentiation and then find the second derivative doing that. The easy way to do this one would be to solve for y first. I know that it's set up to do implicit right now, but it's not going to be hard to get y by itself. So I will do that, getting y by itself, and then we'll look at taking the derivatives. So I'm going to rewrite this equation as y equals, so if I think about solving for y, I would subtract the x to the 6th, and then I would take the 6th root. So I would have the 6th root of 1 minus x to the 6th. Now that I have that, I'm going to find the first derivative. So y prime is going to be 1/6 1 minus x to the 6th to the negative 5/6 power. Chain on the derivative of the inside, which would be negative 6 to the 5th. Now I'm going to simplify that a little bit before I take my second derivative. So the 1/6 and the negative 6, I can make that just be negative 1. So I've got negative 1. And I'm going to go ahead and actually put my x to the 5th out front. So negative 1x to the 5th times 1 minus x to the 6th to the negative 5/6 power. Well, now to do my second derivative, I'm going to need to use the product rule. So I've got two functions here. I've got this function and this function, both requiring an x, both were multiplied together. So again, we're going to use the product rule. So my second derivative is going to be the first times the derivative of the second. So the derivative of the second would be multiply the negative 5/6 down, keep the 1 minus x to the 6th, subtract 1 from negative 5/6, so that's going to be negative 11/6, and then I need to chain on the derivative of the inside, which again is a negative 6 to the 5th. So that's the derivative of the second, first times the second, plus the second, which would be 1 minus x to the 6th to the negative 5/6 power, times the derivative of the first, which would be negative 5x to the 4th. So there is our second derivative. Again, a little bit complicated there, but it does help to actually solve explicitly for y first, so that we can avoid using implicit differentiation there. But if you use implicit, you'll get an answer that will be that will look similar, but it will be the same value there.